everyone. Thanks so much for joining us for this week's episode of When I Grew Up. On today's episode, I am privileged to interview another cousin of mine. If you've been keeping up with When I Grew Up, I've had 3 other cousins on, and it's all on my dad's side. If you listened to the lawyer episode, that was my cousin Alicia, and now this is her younger brother, Jason Kim. Hey, Jay, thanks so much for joining me today.
Hey, Blair, thanks for having me.
I really appreciate it. I know things are really crazy, I'm sure, and busy, but I value your time, and I'm excited to hear about what you do.
Yeah, I'm excited to be here.
Yeah, I mean, so I was just telling Jason that it's been really cool to hear what my cousins do, because I'm the youngest, if you're new to the podcast, on my dad's side, and I'm always been the baby of the family. Right, Jay? Like, everyone just kind of...
You might still be 6 years old in my mind, but...
Yes, yeah, exactly. And so I've never talked to you guys, in this capacity of, what do you do? How do you make money? How do you live? And it's been really cool, finding out different things about you guys. So, I will not talk anymore, and I just want to jump right in. Jay, can you tell us, what do you do?
All right. My name is Jason Kim, and I am a supercomputer systems administrator. Now, real quick, I do work for ExxonMobil Information Technology, supporting research and development here in Clinton, New Jersey. So, quick disclaimer I have to give, which is I'm here speaking solely on my own behalf, and I am not here on behalf of the company, all that jazz. So, real quick, that was quite a mouthful, right? What even is a supercomputer in the first place? So a supercomputer, it's not just a really large or a really powerful computer. It's actually a computer that's made up of sort of normal-sized computers, really. And if you just get a lot of them working together and configured to work together, you can create a large parallel system to use all of them simultaneously. And that is a supercomputer. So an analogy that I use when I describe this is to imagine, say, a dorm room or apartment room filled with 1,000 laptops. So that sounds a lot like the description I just gave, right? A bunch of computers put together in a room. And how is that not a supercomputer? Well, there are a couple of key differences. First is you got to be able to turn them on. At some point, all the laptops are going to run out of battery. And if you try plugging in 1,000 laptops into the wall outlets in an apartment, it's probably not going to work out well. Do not do this. So yeah, you need to figure out the electricity. 2 is that even if you did get all the laptops to turn on, you would have an issue with heat because laptops generate laptops and computers generate heat when they operate. And once you start scaling up to that 1,000 laptops, it's going to make your room really hot. And if you don't have a solution for getting rid of that heat and cycling in fresh air or some way to cool it, all of your laptops are going to melt down. So that's another issue. Third is all the laptops are just individual computers. How do they even talk to each other in order to work together as one? And you might say maybe they're all connected to the internet. I mean, there's of course a big cabling and networking issue anyways, because most apartments or dorm rooms aren't really fitted with the capability to network 1,000 computers in one place. So that's another logistic that has to be filled out. And then even so, beyond that comes the configuration of, okay, now even if you figure out all those things, you now have to configure all 1,000 of those laptops to be equal and simultaneously commandable to work on a single project or job. And that is the essence of having a supercomputer, so much that the career field called high performance computing, or HPC, has arisen from that. And that's the field I'm in.
Oh my gosh. Okay.
Did that take you by surprise?
No, it's not. Well, a little bit, because I thought, it doesn't matter what I thought. I thought you were like in like research and development for some reason.
I am,
Is
yes.
it is that
Like I
it's
said,
like
I work for
a
research and development, right?
okay, so like your title, can you say your title one more time for me?
The title I gave here was Supercomputer Systems Administrator.
Okay, so like your job with this supercomputer for your company is what?
So I take care of the supercomputer. So I'm one of the administrators that um, works on the hardware. I am part of the construction and maintenance. I help out users. We're pretty full stack here. But my typical day, well, typical prior to 2020, it was a combination of office desk work and physical infrastructure work. So I would check the status of the systems. I would do everything from hardware to configuration to operating system to helping out users. There is a customer service aspect to it, of course, in the IT field, doing installation, maintenance, and repairs.
Okay. So um technically, so you're just like not just, but like in my layman's term, like you're an IT person, like
Yeah,
you're like a troubleshooter for this supercomputer.
pretty much. Yep.
That's crazy. So why does ExxonMobil need a supercomputer? Do a
Well,
lot of
most
companies have supercomputers?
yes, quite a few do. Typically in the geoscience industry or oil and energy industry, a supercomputer is often used for geological simulations. A lot of really tough physical science that nowadays just needs a lot of compute horsepower to just grind through the calculations. Other supercomputers around the world, they'll focus on things like astronomy, weather calculations, and simulations, and of course the newest field with GPUs and the latest hardware is coming out. There would be like machine learning or AI and deep.
Right.
These are all things that have become possible now because of supercomputers and how they've evolved over the years and the HPC field. There is even a list called the Top 500 list that gets published twice every year. That ever since the early 90s has tracked the publicly available information about the largest supercomputers in the world. Usually, the the public ones are the ones owned either by universities or national laboratories, stuff like that, and it's served as sort of a benchmark for computing in general. Like eventually, the technologies and the techniques that are discovered with and the boundaries that are pushed with trying to get the most amount of work compute work out of your hardware eventually does make it to the public sector. Like for example, this the phone that I carry around in my pocket that I bought in 2018 is more powerful than the most supercomputer was in the year 2000.
Mm.
And just kind of like that. Now maybe this came as kind of a surprise to you because maybe you heard of me saying that I actually grew up as a chemical engineer.
Yes.
So right. So through a whole process here, hopefully I'll be able to explain that I technically still am. Um, but what happened was by about eighth grade, I knew that I wanted to be a chemical engineer.
What? How did you know that?
Yeah, very young, right? Not too typical, but at least at that age, it was pretty straightforward. Like I had a natural affinity for chemistry and engineering. Chemistry, I'm not sure why. Something about the natural aspect of learning about chemistry just came very naturally to me, and I just enjoyed it a lot. And
Hmm.
engineering probably because both of my parents are engineers.
Right. Yeah,
It's
so
just something I
we've
grew
talked
up with.
about this several times on the podcast with the
Right.
other cousins, like, that we cover all of probably the engineering basis in
Yeah.
each sector, if you
Yeah.
just on my dad's side.
Yep,
But
it's all the same thing. The drive to have that curiosity to try to figure out and solve problems.
yeah.
That's what motivates me and things like that. And yeah, I really just followed through on that vision all throughout high school until I reached, I got my bachelor's of science in chemical engineering.
So wait, quick question.
Yeah,
You mentioned that you've always just had an affinity to like problem solve and things like that. So like, are you the type of person that like if there's a problem, you don't stop until you find the answer? Like, are you that kind of person or
um, maybe not to that extent,
uh-huh.
but more like whenever I solve problems, like maybe it just came from playing a lot of games growing up,
Yes, okay.
doing sort of puzzles and things like that.
Mm.
It, there's something about that problem solving method that just is one of my just drives, my drive.
Yeah.
Maybe it started with growing up with Legos or Connect sets and building things, with instruction sets, and then building more abstract things with creativity. Maybe it was even part of my music training. Like I actually do tie a lot of my affinity for music and our family's affinity for music with what engineering is too. Like it
Mm.
might seem odd to tie such an artistic thing with a very STEM or science and technology thing, but there's actually a lot of crossover, I feel.
No, yeah, definitely.
Yeah. So, however it happened, eventually, yeah, I just something about solving problems in that it's kind of like the same where people suddenly, or rather, people just inherently know that they want to help other people and
Mm.
become doctors or teachers, or or they want to teach and become teachers, that kind of thing. For me, it was just I want to solve problems.
That's so fascinating and so interesting to me. Okay, so you always knew, like starting in eighth grade, that's kind of the direction you wanted to go in.
Right.
So entering college, it was so clear for you then.
Right, and I do recall meeting a lot of people where this wasn't the case. Like I might be able to directly empathize with that. A lot of people go into college, and it's mostly there's no direction, and the college experience is made to give them this sort of generalized experience so that they can discover what they want to do. So in my case, both in high school and college, it was actually a lot more. It was a different type of struggle. It was a struggle because I already knew I wanted to do. That meant I needed a very specific curriculum, and I needed specific direction and support in order to get to that goal. And a lot of things that are designed to not be that specific. So I actually struggled against the school system quite a bit. Like I recall in high school, all of the language arts programs and the electives that were available to choose, I had to go really hard against the grain in order to get the science-based ones that I want. Like I was one of the only people who chose both biology and chemistry to double science as like the optional elective, in addition to computer science.
Yeah, that's a little crazy in my
Right,
opinion, but
right. And I mean, even further, for my senior paper, it was almost assumed that everyone would write a paper that was either based off of history or English.
sure.
I and I fought really hard against the grain to write my thesis about mathematics. And I
Mm.
was the only kid in my gym class that did that. So, and of course, this wouldn't have happened without the support of just fantastic teachers. Like I think I also got fairly lucky with
Mm.
I was in, which were all of my STEM, so science, technology, engineering, mathematics teachers were fantastic across the board, up and down, all the way through college. Like I couldn't have done it. I couldn't have done it without that. So
That's amazing.
that's step number one, right? um, but yeah, even in college, definitely those first freshman years when you meet a lot of people who enter engineering for the various different reasons. They don't even maybe know what type of engineering they want to go into, or they just want to be an engineer because they heard that it was good opportunities, or there were good jobs, or it made a lot of money. And yeah, all those things are true, but it's also difficult, right? Like,
Yeah.
we don't have to beat around the bush here. Like, engineering is difficult, and especially chemical engineering. So the key there is that chemical engineering wasn't just about learning the technical skills, because eventually you're going to have to understand a lot about how heat and temperature works. You're going to have to learn about how fluids move. You're going to have to do all the grind in the science, but also, and let me put it this way: the reason why chemical engineers can often graduate and basically go do whatever they want afterwards is because they've learned how to learn. The only drive a chemical engineering curriculum is to be able to learn.
Interesting.
And that is actually the key skill to pick up.
Yeah. No, I mean, now that you mentioned that, I'm actually thinking about a recent graduate that's in chemical engineering, and he's doing something kind of different than what I expected him to do. But now that you say that, I think it's true. Like, I think he's able to be flexible in his field because his ability to learn and like,
Yep.
yeah, that's interesting. Well, okay.
So yeah, not every chemical engineer can get an oil and energy job. A lot of them, like I can speak for my classmates who went off to work for, some went to work for Anheuser-Busch and became brewers of beers. Some went off to medical school, some went off to law school, and then some continued the traditional education into graduate school for a variety of things, including chemical engineering. But the point being is that that ability to learn is the true thing that you learn as a chemical engineer. So my advice would be, if you were entering school and you really had the drive to do something like that challenging with a really solid payoff at the end too, chemical engineering is actually the way to go. Like, might not exactly align with the course material, or you may, but ultimately it'll force you how to learn. It'll show you whether you have the capability to learn or not.
Interesting. Okay, so let's get back to your job. So like you said, you are in fact a chemical engineer, but how is that consistent with what I think a chemical engineer looks like?
Okay, so another thing that happened, at least during my childhood, is that I grew up in this early computing era. I grew up with the first cell phones. I grew up with the first internet, and I knew from the get-go that this technology would be a part of the future. So even though even though I went into this field of chemical engineering, I always chose different options and choices to use and learn about computers at the same time. And so
you did that on your own volition, like
on my own volition, yes.
oh,
Because I just simply recognized that computers would be part of the future, and that's sort of the case here. Like, when these supercomputers are used in R&D, that's basically a laboratory, right? Like you're running these simulations that are discovering and looking for the science, exactly equivalent to what a traditional chemical engineer would have had to do at a laboratory setting, or at some distillation column to process your crude oil or whatever, right? So and that is in fact how it has turned out, and is still projecting to go in the future. So I made it okay, my parents helped out a little too. They kind of understood that computers were important to at least teach me how to type when I was 9 years old or 8 years old or whatnot, and use basic computer skills and things like that. But beyond that, I learned what software programming was, and that eventually led me to this job. And more in specific, being in the oil and energy industry, having the knowledge, I still use direct information that I learned as a chemical engineer to apply to my job. Like ultimately, it does help to at least understand the concepts of what your customers are trying to do. With the computer, it does help out, and to at least understand the industry and the science behind the industry, especially in R&D. So a lot of my job is sort of this hybrid mix between maybe what that traditional IT system admin would be like, except it's for a supercomputer. And I'm not the one doing the hard traditional chemical engineering either, but it's sort of that overlap between the two where we all work together to get these research problems looked at.
Interesting. I just never imagined. I mean, I say this constantly on this podcast, but like there are just so many jobs that I don't even think about, And it's like so crazy. Okay, so right out of college, like were you like looking for this type of job? Or
mostly, yeah.
Oh, so you knew like what you were looking for then.
Kind of.
Okay.
When I remember my specific job searching had a small little directional event that occurred, which was I was in college when the Texas City incident happened.
What's that?
So that was when there was an explosion in Texas City at a BP refinery, and
I remember a little bit.
Yeah, right. There were a lot of casualties and incidents. It was like a huge thing, and as a growing chemical engineer, I was kind of shocked by that because I was like, wow, that was me, right? Like the people there were basically like what I was going to do. So I had to think pretty extensively about like what I was going to do in terms of like my future career, like how it, because it really could literally affect my life, right? I'm certainly happy that I went to at least a company that was very safety conscious, but also the opportunity to work in research and development for the first place. Because after college, I basically decided that I was done with schooling. I said that I've fought the system enough, I've struggled enough, I've gotten as much as I want, and I want to go out there and work. And I always really liked, that research and development style of study and work. So the thing is that most R&D positions or positions with R&D don't require it, but most assume that you're at least at a PhD level or above. But I said, no, I would like to work here. And I got the job.
No way. That's not how it went down. There's more to this story.
Oh, really? I interviewed. Technically, I first interviewed with the traditional engineering in, back then it was in Fairfax for ExxonMobil. But then they were like, you know what? Why don't you try research and development in Clinton, New Jersey? And then I interviewed up here, and that was just a better fit. Yeah, I could use all of my chemical engineering background training. I could use all of the extra efforts that I put into learning about computer systems and software development, and that's how I landed my first job.
So you're saying that normally this position that you currently have, they kind of require or expect to have a PhD level degree. But you're saying
not my specific position. No.
No, but in all
technically in all of R&D in general, like
right.
I'd say about 75% of people that work in R&D with PhDs.
No, I don't doubt that at all. Right. So I'm just trying to let people know, like, that my cousin is a genius. But no, but in real, like, for real though, like I'm sure people are wondering, like what I mean, was it your grade, like your grades, your performance in college? Was it like the way you interviewed? What was it that they were like, you know what? Like he is capable of doing this.
Um, Honestly, it was a lot of it came from the fact that I survived chemical engineering. Like it might be that.
Really?
Yeah, like people who are able to come out of chemical engineering, you can expect that they have learned how to learn.
Hmm.
So the other question, or the other side of this, would actually be people questioning, because my first position wasn't actually in supercomputing. My first position was in a group called informatics, where we did data workup, and I was actually a software programmer. So the real
Oh.
question was, how did you become a software programmer without actually having
Yes.
science background? I didn't,
Yes.
like you'll notice I said that I did not even major in computer science. Well, what happened was that in my chemical engineering curriculum, there are occasional cases, like we did take a programming class and we did do things on the computer. And here's a small secret, but chemical engineers are typically not good programmers. They're
I mean, yeah,
typically not good with it.
I
So oftentimes there's often group activities in engineering, and when it came time to do these engineerings, I would step up and be the one that would be either the one that did the programming, the one that did the SolidWorks to do the 3D modeling. I would be the one that was doing the Aspen. In I don't know if they. I hope they still use that in chemical engineering. But to draw and simulate the distillation towers, and I was the one that coded as well when we had to do C programming. So over time, I just kind of became known as the chemical engineer that could actually do it. I became trusted in my class to be able to actually program things or do computer things, and everyone else was kind of bad at it. So I just did.
yeah, just took the reins, man. So
Yeah.
coding too, like, did you learn that or you taught yourself how to do that?
A lot of it is self-taught. The basics of object-oriented programming I did get in school. I didn't really understand it beforehand, but yeah, I really did have to, through at least through my first assignments and through my current one as well. I basically taught myself all of that. Yeah, all the aspects of programming, and now all the aspects of Linux and the Linux operating system.
I
Um,
don't, is that a language, computer language?
it would be like you have Windows, Macintosh, and
Oh,
Linux,
I see, I
the
see,
big
I
operating
see.
systems. What runs the computer, right?
Listen, I'm like clueless right now. Okay.
So it's okay.
But okay. So you started in computer programming with this company then. Software programming.
Yeah, pretty much.
Interesting. That's so cool. So like, I don't even know. I should have like asked you before this interview started, and it's okay. If you feel uncomfortable answering it, just say pass.
I'll
Okay.
let you know when we get to the point where I can't reveal confidential
Okay,
information.
yeah, because I'm
That I
sure
work
there's
for
like
R&D.
confidentiality
Yeah, yeah,
within, research and development for an oil and energy company. I mean, for sure
right.
there's confidentiality. But like so oh man, so like is it true that like you did something to like help the company? Is that true?
I mean, I do that all the time.
No, no, like really big, like you did like something with the software and it helped the company.
In the most general terms, of course, yes. We have quite a few users of the supercomputer. In addition to my old job, like our particular. Okay, I'm going to go on a very quick side tangent of describing the public facing portions of our R&D.
Yes, okay.
I can boil it down to, if you've seen a commercial or a YouTube video that is about actual technology from ExxonMobil and not one of the marketing or gas station commercials, but the actual ones about technology, that has most likely come from us in Clinton, New Jersey.
Uh,
Going backwards or reverse chronological order, things like the carbon capture initiatives, the algae biofuel projects, the hydrogen fuel cell battery film, things like that. That all came from our site, and I'm just going to simply say that it's all real, and even down to the people in the commercials themselves are in fact real scientists that I work next to.
So cool. My cousins are so cool. I just feel privileged to be in the same like family as them. But I wanted to ask you a more specific question, but I feel like it's going to get all of us in trouble, so I'm not going to ask. But anyways, so, do you like what you do, Jason? Yeah, what do you like about it?
Oh yeah, absolutely. Being able to work in research and development is certainly a privilege, and it's so great, especially for someone like me who just really loves that that scientific discovery and things like that. It's actually probably the closest that the public sector gets to the private sector gets to the public sector or academia, because that sort of it's called blue sky research, where you're trying to research really brand new concepts, novel things, and you're just surrounded by all of that, right? And of course, I'm just surrounded by so many clever scientists, and I am just constantly learning every day. I learn more and more about being now specifically being a system administrator for Linux. I learn more and more about hardware, and like I said, I am still a chemical engineer, so I learn more about now electricity and water systems. Something that's happened to supercomputers of the past decade is that you basically can't have a supercomputer without water now. Back in maybe 2006, it was pretty much unheard of to have water anywhere near a computer. It was you cool the computer with air and fans, and that's the only way it works. Around 2009 is when more of the first, and so when the first speech or the first lecture was given on this concept, everyone basically just called the guy crazy, right? You can't put water into a computer. It's a piece of electricity. What are you doing? By about 2009 is when the first installations started occurring, and by 10 years later, 2019, at least 2017, it's basically now unheard of to have a supercomputer without some sort of water cooling component, because it's that good and it's that efficient. You use water to cool your computers instead of just air. And so
my mind is
right
now.
As part of me. So now the heavy implication is you do have to understand a little bit about heat transfer and water flow and water systems, especially in their conjunction with computer systems. And that sounds exactly like how I was raised, of chemical engineering and computer science. So that's the other thing about this is sort of a difficulty in addition to being the great part of the job, which is this industry, high performance computing, moves very, very fast. You have to constantly be learning and constantly be researching the current and future technologies to keep up. Everything evolves in HPC so quickly because it is cutting edge, because it is leading the way for the entire world, basically, on what's going to happen to computers. It sort of is the benchmark of what we as even human beings have been able to accomplish with computing resources. And there's an entire history of that too. It's all graphed out now. Again, top 500 is the way that you at least track that through since the early 90s, but it's been a constantly growing field, and you can see how all of the hardware and the configurations of these supercomputers has progressed over the years. Just having a lot of flexibility and just natural interest in it is what I love about this job too. I like I said, I can work remotely, but because I am the one that's also the hardware infrastructure specialist, I have had to go into work every once in a while, even throughout this COVID-19 pandemic, and that's certainly been its own set of interesting stories there.
Like
But
what? Can you tell me one? What's an interesting story?
yeah, sure. So again, like I said, we're here in New Jersey, so that means we were one of the first states that was hardest hit in the United States.
Yeah.
But so by about mid-March is when everything started shutting down, and we were told to go home, and the executive orders started coming in. And around April was the first time that enough stuff had piled up that was like, okay, someone's got to go into work and get it checked out. And but the thing is, around mid-April, like the stay-at-home and lockdown order was very serious in
Yes.
the point that there like police would stop you if you weren't supposed to be on the road in your car. So I actually had to get permission and a letter to show to police that I was okay to be on the road because I needed to go do something critical, right?
That's crazy.
And of course there was a whole experience about like what the cleaning procedures were, and not to mention seeing a building just like population of no one inside, right? As opposed to something you're so used to seeing bustling, and you look around at all the cubicles and it's like, wow, will the concept of cubicle even exist after this? Like what is going to happen? And there were all these questions, and there was the faint smell of a hand sanitizer just everywhere. It like almost like a hospital, right?
Yeah. Yeah.
Man, yeah, it was
Crazy.
wild those first months, and over each subsequent month, like I've still sort of had to go in every once in a while to take care of issues and maintenance and things. Yeah, I've sort of gotten to see firsthand at least the New Jersey state response to how things have changed.
Mm.
Yeah, even the concept of like eating lunch at work has
Right.
has evolved, right?
Yes.
Yeah, so that's definitely been an experience. So yeah, I haven't had to, or rather, I haven't been able to work completely from home for my particular job. But yeah, that is definitely been something that we were not expecting at all.
Yeah, I mean, you and the rest of the world.
Yeah.
It's been so crazy. But anyways, to continue what we were talking about, I just was really curious to like, how things have been evolving for you in this situation. And thank you for answering it so transparently. Um, but yeah, so you were saying like you enjoy the flexibility of just even, I mean, you seem to really love what you do, Jason. Like,
Yeah.
what a gift, Like, not everyone can say that.
Yeah, absolutely. Those are probably some of the luckiest things that happened to me coming out of school, which was
Mm,
really finding a job and a position that matched so well with not only my interests but the skills that I have developed.
yes.
The other lucky thing was, unfortunately, timing. So, and I say that unfortunately because I know what happened after me. I graduated in 2007,
Mm-hmm.
and there was still just a good job market. People could get jobs at a fairly regular pace, especially for engineering.
Mm-hmm.
And and then 2008 and
Yeah.
later hit, and things changed drastically. So that is something that I just have to mention, which is sometimes it unfortunately can just come down to luck and timing,
Yeah.
these types of things. But the good part about, at least about engineering, is that it's such a core technical skill.
Mm-hmm.
As if you're able to do it, like you should be a lot better off in terms of finding a job or making a living for yourself, or at the very least having the flexibility to learn and continue on and pivot to something else.
Right.
Like this all comes back to what I said about chemical engineering, right?
Right. Yeah.
We need to be learners.
Yeah. That's
Um,
great.
yeah, and I guess other benefits of like the engineering career path is that like I know that there's a phrase that's common with some careers where it's like, oh, if you want to advance, like it really, like none of that actually matters. Like it just really matters who you know, right?
Yeah, like networking and stuff.
A
Yeah.
bunch in other, yeah. So the plus side to engineering is that it's probably the career path with the least amount of that, um,
Mm.
where you can heavily um, do performance and skill based like merit, or use that merit to get at and be successful at your job.
Mhm.
But don't get me wrong, there is still a small portion of that that does exist. So technically, like you have to be comfortable not only in your technical skills, but also the more traditional soft skills and business skills and teamwork interactions and all the different business interactions as well, at least to some minimal amount.
Mm.
And that's probably the recommendation I would give most to any aspiring chemical engineer, which is yes, it is really hard. The information you're learning and all of the raw classwork learning and skills that you're doing is hard. It's going to be,
Mm.
everyone knows that, but don't neglect the other side. You still need to be able to work in teams. You still need to be able to communicate. You still need to be able to develop personal interactions with people and establish relationships, and just go a little above zero or a little above minimum to pay attention to the development of those soft skills, because I know you can do it. If you're already in chemical engineering, then I know you can learn how to do that stuff. But it's not just about the learning curriculum. Like I think I even give our little cousins on the other side that advice starting middle school, which is yeah, when you go to school, yeah, you're there to learn, but it's not all about what you're learning in the classroom. It's not just learning what the teacher's telling you.
Mm.
Really learning about the entire school experience and the experience of interacting with other children, with kids that could be just the worst bullies you've ever met in your life, and maybe the greatest person who will become your best friend for life, and everyone in between. And most people, this just comes more naturally to them. Maybe more extroverted people, this comes more naturally. But for me, I would say that I'm probably the most introverted out of all five of us cousins. So for me, these skills are not, they just don't come to me as naturally. Like as much as I have an affinity for chemistry and mathematics, these soft skills I just don't do as naturally.
Mm.
I know that, like Blair, when you grew up and stuff, like I know that you were able to always you're able to always capture a room. You always had a shining confidence that you're able to say what you wanted, and to always speak your mind, and to be like strong and very like, well, a little more extroverted about it. But that was not the case for me. Like talking was difficult, interacting with people was difficult, and that would be my recommendation, which is to not neglect those skills as well, because ultimately soft skills are still skills.
Mhm.
Being able to at least above a bare minimum, still at least respect that adage of yeah, you still want to develop relationships with people and build trust, because ultimately that leads to teamwork efficiencies, and ultimately that leads to better productivity anyways.
Mhm.
If I may put on a very small business manager hat there, but but yeah, being able to work in inclusive teams, being able to communicate effectively with multiple different types of people. Like I said, if I interact with not only customers but also team members, and then business managers, there are different types of languages that you use for all this. And oftentimes when you're in engineering, language and these soft skills are something that are just more neglected.
Mm.
So yeah, I would say don't neglect those, and keep working on them.
Yes, I mean, I absolutely love what you just said. I think there are people listening that struggle, and these are the obstacles for them, and they really need to hear it from somebody that's been there and is succeeding in life right now. And I feel like, yes, of course, those are good tools. I personally don't feel like it's that important, but for somebody, and like you said, I think obviously you and we have different strengths and weaknesses. I can never do what you do, ever, never. And so, and
I don't think I could ever be a podcast host.
yeah.
It's just not in me.
But all that to say, yes, I think I loved what you said about like school is not just about education. It's about so much more. And if you miss out on it, you're going to miss out on other opportunities later on in life. And I think that's so great, Jason. I'm like, yes, I need, like, oh, honestly, when you're talking, I'm like, oh, I need to tell Eli and Zoe this. Like when they're
yeah, unfortunately for me, I learned it just a little too late. So,
no, that's not true.
Yeah, no, it took me a while. It definitely took me a while. Like I actually remember on my wedding night was probably, or sorry, the night before my wedding night at the family dinner.
Mm-hmm.
It's the first time I ever had to fully flex and use like basically every single social skill that I had developed in my entire lifetime. And it was like one of the most challenging things I've ever had to do, to go around and work a room and to like talk to all the different, like every single different type of family member that was there.
Yes.
And things. I very distinctly remember that being like one of the biggest challenges that I've ever done. But then also like it's just one of the most striking moments of me like just nailing it, actually doing that sort of extroverted thing. And I see the look of amazement in your face a little bit, but that kind of thing is not natural to a person like me. Like that had to be learned and practiced and trained at least up to that point to get anywhere close to that. And honestly, that moment was such a blur as well because, there was just so much happening at once.
It's so crazy. No, my face right now, Jay, is like I remember that night like so clearly. I don't know why, but
So this was 10 years ago for everyone listening.
Great, you were great because like I think for me, it was kind of a whirlwind experience for myself as well. I mean, just some background, like Jay, he did something I would never imagine any of us doing, but him and Lisa found each other in the most unique way. Is it okay if I share this a little bit?
Oh yeah, go for it.
I mean, you should just share it, but your version is probably better than mine. But I just real quick, on that night, the rehearsal. You're talking about the rehearsal dinner, right?
Yeah.
Yeah, I mean, like, it's funny that you bring that up because I remember that night so clearly, and I remember thinking like, oh man, this sucks. Like, this is a lot of work, because like having to talk to everybody, and then like you did the humble thing too, right? You guys did all that and everything. I remember it's like a lot of work, and you guys were so great, and Jason, thank you for being so transparent that was not an easy thing for you, because somebody that is introverted to like admit that, you have to work towards this is something that's so refreshing for me to hear. And, but yeah, like, oh yeah. So anyways, going back to the whirlwind, for me, it was just like, what's going on? Jason's engaged and getting married, and like it was a surprise for me. And then they told me, "Hey, you got to fly out to Arizona," and I was like, "What? Like, what's happening?" But I was like, and then again, I had this complex of like, no one ever tells me anything. Like I'm the youngest, and everyone leaves me out all the time.
That's partially my fault, since I'm the worst at spreading news or gossip or anything like that.
No.
Right. So, but this did come on really quickly, and hopefully this ties together in a very similar fashion to me describing how in 8th grade I just knew I was going to be a chemical engineer. In in 2010, I just knew that I was going to marry Lisa. That's just how, like, this comes from my this comes from my dad. So
Yeah, sure. Yeah, you're right.
so this is how he functions too. Like, there are just some decisions that I just know what to do. There are some problems that just get solved in my head. So the entire courtship process, that people typically go through in terms of like relationships and commitment and things like that. Like, I did the very engineering style analysis in my head, and everything checked off, and I just moved forward with it. Like, that's just sort of how things happen for me.
Wait, you're missing the core part of the story though. Like, so how did you guys meet? Tell us your love story, even though it was a very calculated love story.
Okay, the real quick how to find love tangent, right?
Yes.
So yes, by 2010, I've been working at my job for 13 years, and since 2007, hired right out of college, and by about 2010, I was about to turn 25, which that was sort of the agreed upon age with my mom, to say, okay, if I don't, go do my own relationship thing and make it by the age of 25, then she would start, playing matchmaker. In Korean American families, that means something slightly scary.
Yes.
The impact of what that could imply with our elder cousins previously. But it was fast approaching, and I was 24, and I was actually almost resigned to sort of giving up. Like, I was out here in New Jersey. I was kind of alone, and I was kind of just working by myself. And at around this time, the concept of internet dating was still kind of new, but
yeah, so like taboo at the time, I feel like.
Right. So I was right around the time when it was less taboo, but it maybe just wasn't as common.
Sure, but now it's like, why aren't you internet dating?
Yeah, it's super straightforward. Any level of relationship you want to find, there's an app for it now.
Yeah.
So yeah, of course. But yeah, certainly back then there were only like a few different resources and things like that. And I looked into them, and I tried them out, and they were okay, and I got some dates and I met some people, but overall it wasn't really working out. And at some point I was just playing a normal game online, and I was just talking to one person in that game, as you would, and we just kept talking, and it just sort of eventually led to us talking over Skype, since this person was not in the United States but was in fact in Germany.
And, Germany, people. She was in Germany.
and as we talked more and more, it just, like I said, I just did the analysis in my head and said, this is for me. So that process of first meeting to flying to Germany to go pick her up went from about February of 2010 to July of 2010.
I love it. Such a great story.
Yeah, and honestly, when you look back at it, it's like, yes, I met a girl over the internet to marry her, but technically it was really just like any other chance meeting that you would have in a standard like love story. It's just that in our case, it happened to be supported by the technologies of, one, an internet game, and then two, Skype. Like, if Skype didn't exist, then this relationship would have never happened.
Yeah.
An interesting callback into what I said before about recognizing that computers and the internet technologies would be a key part of the future.
Absolutely.
So I'm pretty glad I at least figured those things out. But yeah, it really was just a chance. Like, it wasn't even a dating website, or it wasn't anything forced. It just sort of naturally spawned, just like two people could have met at a bar and had the exact same thing happen.
Yeah, man, I actually never heard this story. I've always heard like secondhand stories. I never asked you directly. So that's
Right.
really cool. Wait, okay,
And I'm
so
sure the just the speed of how it happened was
yes.
the most shocking thing for
And then I was at the rehearsal
outsider
dinner and you
perspective.
guys were just killing it. And I was like, whoa, okay, like I guess we're just gonna do this. Cool.
Yeah, no, I definitely get that. Like, and I'm certainly super duper thankful for all the support from my family,
No,
but it's
of
probably like
course.
I did not even give anyone a chance to even breathe or respond back because of how fast it was. Like they thought, like my dad actually has a very similar courtship story to my mom, only the amount of time that it took is about double than what I did.
Right.
So when he heard me like going through the process and describing what I was doing, because I had to be like a little secretive about it, like, hey, I'm going to Germany. Like he could sort of figure it out. So like by the time I came back to the United States, it was like I'm getting married. My mom and dad were pretty kind of like ready to go and just get the process of all that marriage stuff put together. Like because the original plan was I was just gonna do the marriage license in New Jersey and that would be it.
Yeah.
They put together the entire thing to make it like suddenly every single family member, which is unheard of, right? Especially on both sides of my family, every single family member could basically make it to that wedding. And I feel like, and a lot of it was mostly out of just shock and bewilderment at how fast and how sudden it came on. Because it was like, wait, what's happening? Right? But that's just the type of person I am. Like, hopefully I've displayed from all of my sort of career planning decisions and things like that I just make those types of decisions more confidently and securely than other people do. Like that concept of commitment or relationships I just viewed and analyzed differently. And we're still married 10 years since.
Yes. That's so okay. Sorry, when you were talking, I just thought of something I wanted to ask. And you were saying, when you make a decision or you commit to something, there's no, like, that's it, you've decided, and it's so clear to you. But, like, in that clarity, is it are there, like, an analysis being happened in your mind? Or,
Oh
like,
yeah.
okay,
Yeah. So the typical engineering type of thought process for that is it's always an iterative process.
what is that? What word
So
did you just use?
iterative. So it's always a circle.
Okay.
When you go through a brainstorming process and you come up with an idea and then you analyze to see if it works and then you come to some sort of conclusion, typically more information will always come around that will always challenge that conclusion. So you always go through the cycle of saying, okay, is my conclusion still valid? Yes, and then move on.
Mhm.
Oftentimes problems end there, like nothing else changes, so the conclusion that you had is still good. But but when it came to like marriage and things like that, I went through a lot of iterative cycles going through my head to both affirm that she was in fact the one for me, and I would always constantly challenge myself saying, am I just being desperate?
Mm.
That was a trap that I saw a lot of people who are like me fall into. And so I wanted to make sure that I wasn't just making a choice just for the sake of making a choice, Like
Yes.
I did really think about it. And of course, from the outsider's perspective, it's like, what do you mean you met a girl in 4 months and then 3 months
Guilty.
later
Guilty.
you
I
got
love
married,
Lisa.
right?
I love her. But I'm totally guilty of what you
No,
just said.
I totally get what it looks like because the normal people, this is completely insane. Right? This is not the way that you make decisions like this. I mean, you hear all the time about guys who are just like, who fear that commitment, right?
Mhm.
Who do that things. But for me, as every time I went through the iterative cycle of analyzing what was happening, it just kept on coming up positive. It kept on saying, yes, this is correct. Like I could even say like, okay, oh man, this might be this might be a TMI.
No, it's not on this
Okay,
podcast. Keep going.
slight relationship tangent, right? So you know how sometimes if I get caught looking at another woman, or if a man in a relationship gets caught looking at another woman, oftentimes that would evoke a feeling of jealousy, right? Because it's like, what are you looking at her for, right? Like, and you know how that can traditionally
Sure. Okay.
devolve, right? But for me, every time I see just another woman in whatever context, it actually kicks off an iterative cycle, and every single time it says, I say, could this have been the woman that was actually my wife? And and every single time it says no, or it's like, is this woman better than my wife? And it's like, no, because my wife's my wife. And that actually goes through, and actually every single time that I see, like, even in someone that I would find attractive, it actually just simply solidifies my current thought and like conclusion that my wife is my wife. And
Oh,
it's
sweet.
I know it's the most weird engineering style,
and it's so dorky
culture.
all at the same time, Jay.
But I mean, that's just kind of the way our brains work. And
yeah, that's
for people
crazy
to understand
though.
that
I
might,
like my brain does not do that, and I think that's so interesting. So okay, going back to what we were talking about, which I love this tangent. This is my kind of tangent.
Yeah, that's how you get over the fear of commitment. So there's my advice there.
But I mean, so like even in problem solving, your brain must work like that. Like different solutions. Like, how are we gonna fix this? Oh, this doesn't work, so we'll just go this way. Is that kind of how it happens?
Yeah, that's sort of the basic outline. And there are some nuances that are different when you look at problem solving with computer programming. There are some nuances or differences when working in the HPC field, and especially working with the hardware itself, let alone all the other complexities of keeping a supercomputer up and running.
Mm-hmm.
But yeah, that basic in core science classes, it's called the scientific method, right? Or that sort of create a hypothesis and do the observations and then find your conclusion type thing. It's all at the raw level very similar. And in engineering, yeah, it's effectively the same thing, right? Mm-hmm. There just might be more different complexities with
sure
the technical portions of it because of a very specific engineering application. And that's probably another thing that's really good about engineering, is that it is one of the fields that you do directly affect people's lives. Like, maybe not as direct as first responders or people saving people's lives or things like that, but the decisions that you make and the things that you do in engineering, they can affect how the world is. Like all of the core infrastructure of the world. And I guess you've probably talked a lot about this in various aspects with the other cousins, but or maybe not. I'm not sure, but yeah, you it's a lot more direct than, say, a physical science, where you're just making observations about the natural world around you and sort of trying to understand like how everything functions. In engineering, you have to say, okay, now that I understand enough of that, how do I apply that to actually impact people's lives? And there is like an entire set of engineering ethics that go along with it. It's not as well known or as hard as the medical one, but there is still like these ethical decisions that you make as an engineer as well. So by the way, throw that on top of the pile too. So yeah, you have to not only be technically proficient. Now I'm saying that you also have to have good soft skills and communication. But also there is an ethical component too, and like you do have to be somewhat psychologically strong and prepared to make
Mm,
these types of decisions, because people's lives could be on the line, exactly like Texas City.
yeah, absolutely. Man, excuse me. No, I mean we definitely talked about that with other cousins, and I mean I talk to David about that also. He's a structural engineer, and he's not doesn't have his professional engineering license yet. But having a PE is a big deal. You're literally signing off on people's lives and the buildings that
Yep.
they're building. So, I mean, engineering in all aspects, it sounds like is I mean, it's critical to our way of life, honestly. Like the things that we don't even think about, um, engineers are responsible for it. So, yeah, absolutely. Jason, is there anything that you don't like about your job?
Oh man, not too much, honestly.
That's great.
Probably, although I do have to say that the the constant learning can be incredibly difficult.
Mm.
It may almost seem, from an overall perspective, like kind of fruitless. How if you learn, like I would say that generations of HPC technology cycle about every 3 years, give or take.
Oh,
Uh,
that's really quick.
right, about as quick as like actual real upgrades to,
Sure. Yeah.
if you can imagine cell phones in 3 year intervals, right?
Yes.
How different they've been. And imagine, like, at the cutting edge of all that comes all of these new technologies. Like I said with my water cooling example, like a decade ago, I could have, or any generic HPC sysadmin could have known absolutely nothing about water cooling, right? We were just all about computers and IT. Now it's like I am the facilities and water cooling overlap between making sure that water is coming to our supercomputer and that we're using it, and everything, all the logistics involved with that, right? That would just be a completely new skill that had to be learned.
Mm-hmm, mm-hmm.
Skills will cycle way faster like skills already cycle very fast in the IT industry itself anyway,
Sure. Yeah.
but even more so in high performance computing, like double the speed. So you will see a lot of skills and technologies that you learn become obsolete way quicker, and that can be kind of disheartening, right? But at the same time, if you really enjoy learning and you like learning new things and seeing like the cutting edge of technology, then this is the right field to be in.
Mm. So how do you keep up with all the learning? Like, what do you have to educate yourself, or
A
are
lot of
there
training
classes?
classes. Oh yeah, there. It's a combination of classes. It's just keeping an eye on generic news in the field. There are conferences to go to. Were conferences go to now. Now a lot of them are virtual. But yeah, there are just resources, a lot of resources around the industry to help try and deal with this. And well, notably, a lot of those companies in the industry are trying to sell their product to say that we are the next thing that you should invest in learning about us, right?
Right,
So
right. Yeah.
they have an expressed interest in teaching you as well. It's sort of that win-win situation. But yeah, there are almost certainly, if you have a preferred method of learning, which hopefully through succeeding in the chemical engineering degree, you should be somewhat familiar with which methods of learning are more effective for you and which aren't. That's another key thing to try and figure out about yourself. But almost always there will be a method that is available for you to learn from.
Yeah, it's good. So we're coming to the end of our time together, but I
Mhm.
usually ask people, if they have any advice, but I feel like you gave a lot of sound advice already. But I do want to ask, maybe for someone that is thinking about going into chemical engineering or currently in the studies of chemical engineering, in the middle of it, do you have anything you feel like you would have done differently, or do you have any advice for like maybe getting ahead of the game?
Oh yeah. So yeah, definitely. If I could have done it differently, mostly no. Like mostly everything that I chose on a technical level was fine. Um, and I think I mentioned it before, but the thing I would have definitely done differently was uh, develop more soft skills during
Mm.
learn more about interactions with just other students and with professors and teachers too.
Mm.
Who again, thankfully, I had such good teachers in science and mathematics fields that they could just teach me and I would just absorb it. In fact, at some point later in my education, I recognized that this was actually me being kind of gullible. Like, one of the things with my introversion was I was actually a very gullible kid,
Mm.
which helped me learn in a certain way up to a point. Because if you think about it, if you're just really gullible and you're told things by a teacher, you just absorb it and take it, at its sort of face value. And that's a really quick and easy way to learn. Um, which also means that if you have a bad teacher, you are not going to absorb anything at all,
Right, right.
and you are susceptible to getting scammed, information implanted in you. So like I'm really trying to hammer in, like I had some good teachers and I am so thankful for
Mm.
them for leading me down the right paths and to giving me the knowledge in a way that I could absorb.
Yeah.
But at some point I recognized that this was not a sustainable way for me to learn. So while it is useful, you do still need to be able to question afterwards, to analyze everything that you have learned afterwards, to vet it, and then be able to know how to react to that after that. So, for example, like maybe um, uh, in my student age, if I had seen, for example, a math problem that was graded incorrectly, um, I might have like gone back to the teacher and try to argue my case for why it should be changed and things. And I could have seen myself in those situations doing that in a very, very poor way. Like doing that in a not in a way that doesn't like actually accomplish anything good or doesn't actually build any trust with my actual teacher. Just attempting to go in there and just like hammer down my point of view.
Sure, yeah.
Um, Nowadays, I would know how to navigate that social interaction with a little more tact, in addition to being able to apply like the technical knowledge I have. So that would be like in hindsight the thing I would do differently, which is
Mm.
how to actually interact with different types of people way earlier, and also to figure out how to not just learn because I'm gullible, like to actually go the next step in critical thinking styles and learning styles. So because okay, what the last anecdote from my school days, which was in sophomore year of college, we had in one of our chemical engineering classes, we had an exam, and I woke up late. I woke up late, and I was like, I rushed over to the lecture hall. I entered 30 minutes late, and it was only a 50-minute class. And I walked up to the front and was like, "Can I still take the test?" He was like, "Yeah, sure, go ahead." And I just was that was the most laser focused I ever was. I just went as hard as I could on every single problem, finished it off, and turned it in exactly when the bell rang. Right. Next class comes around, the tests are graded. This was a pretty big lecture hall, so it was about like 50 to 60 students, right? and they're like, all right, here are the tests, graded on a curve, etc. Let's see, three of you got 100%. And I actually specifically remember someone like within earshot gossiping, like, it couldn't have been that kid that walked in 30 minutes late. My kid's probably screwed. This was hard. That test was so hard. I get my test back, 100%. Could not believe it. And it was like playing Russian roulette and dodging that bullet. And it was like an experience that I just never forgot.
Oh my gosh.
It taught me a ton about well, one, it taught me about my latent learning ability, right? Which I was using as a crutch. And two, it taught me about like actual responsibilities and things like being late and procrastination and things like that.
So in your mind, you were like, for sure, I'm not one of those people.
I thought I failed, right? I thought I failed.
Interesting. That's
I could
so
barely finish it in time, and I rushed, and I made every decision as fast as I could, almost like at the expense of accuracy, right?
That's crazy.
Yeah.
Okay, so
don't do that.
Yeah, don't do that.
show up to tests on time.
Oh man, that's great. Oh, so what about can you speak to my question about maybe something they can do to like I said get ahead, but I don't know if that's
right.
really what I'm asking. Like do you know what I'm asking?
Sort of. And I think in today's at least with the internet now being well more fleshed out than
sure, yeah.
Now like a ton of like resources available. If you have an interest in something, like you can just go look it up.
Right.
Video tutorial about it. There'll be someone that has written about it. There'll be, maybe there's a blog about it. Maybe there's an entire YouTube channel dedicated to it. Maybe you can just browse around and find your interest, but go use there are at least resources out there for you to go it alone. I could have only dreamed of having something like YouTube existing when I was growing up, to look up all of these programming concepts that I was just naturally trying to figure out on my own. Like, oh my gosh, my early attempts at learning object-oriented programming as a child were terrible. They were just awful. I was the worst, and I had to keep like restarting. Man, if I just had like a whatever simple YouTube course of 30 minutes that I could have watched as a kid, that could have jumped me all the way up to where I was programming wise at like to a junior in high school immediately.
Yeah, isn't that so insane?
Yeah.
So insane.
There are resources out there.
Yes. So just be proactive is what you're saying.
Yeah. If you find an interest, like look into it.
Yeah.
And there will be something out there to at least help you out to investigate what that is. And the other thing is like don't be afraid to switch out of it also. Like they called them weed out courses in freshman year of engineering for a reason, because they did weed out people who weren't there for the right reasons or weren't even there with enough motivation, the correct motivations. Like go discover what your motivations are. That's how you get ahead. If you can like it's not going to be like me where, like I said, I knew in 8th grade what I was going to do, but if you do have like an inkling into some interest in the science and technology field, like investigate it. Like don't just drop it. This is actually especially a message for young girls out there, because I've done volunteer work to do STEM education for women in engineering and girls in engineering.
Oh, cool.
And often what happens is that it becomes viewed as like socially not cool or a social experience to continue to enjoy science and mathematics. And very, very slowly over time, that's changing, but it's still not there yet. Like, be okay with finding what you want to do and enjoying it. Like, like find the confidence and inner self-esteem. You notice how I'm not describing anything about actual engineering technical skills at all, right? if you want to get ahead in engineering, it's all about discovering yourself.
Mm. Yeah, like being more self-aware too, I think is another thing that I heard as you're talking. Man, all great things. Jason, thank you so much for just imparting your experience, and I really appreciated your transparency today because I feel like I learned so much about you. And I know anyone listening is going to really find this talk insightful. So thank you again. Um, for those of you that have any questions about chemical engineering or research and development or computer programming and all the other things that Jason does, I'm sure, would you mind somebody reaching out to you if they had any questions?
No, that's all right.
Yeah, so I'm sure he would love to chat with you. I'm just like talking for him, but please do not hesitate to DM us on our Instagram, or you can email me at podcastwigu@gmail.com. Thank you again, Jason. Until next time, guys. See you later. Bye.